Hello everyone, Peter here, Piotr Fissner. Guys, yes, you see it right. It's a welder. I fix household electronics, you know. I'm talking to people. Bring me household electronics. Look, I sold a PSU and I said, do you have the old one, faulty Xbox One? He said, yes, I do. If you want to bring it, I can attempt a repair. That's not a problem. I don't have to charge even the repair attempt fee on these. So, because I've got some time in hand, yes, and I know most of the faults with them, and if I don't, there's not like, you know, something that you can't cope with, or it's burned and you don't want to touch it. And you can use some parts from it to fix another one. So, you know, so I said, bring it in, you know, like 10 to 15 pounds and it will be fixed probably, yes. So, guy paid 20 pounds. Yeah, 20 pounds I'm charging for the Chinese one. So guy took that one and, you know, and brought me this one. I will attempt the repair. If no, I'll have it for spare parts because I've spoken with him. But I need a recording when I will be doing it so that he will know I didn't cheat. But I don't fix such things, you know. People are bringing radiators, electric radiators. People are bringing me hoovers. People are bringing me white appliances. Come on, guys. And now I've got a welder. Believe it or not, I removed capacitors. I've checked the capacitance with capacitance meter and it's fine. Yes. So the tolerance on the meter was like 10%, so it's fine. I've checked diodes. Not shorted, not open, no OL, open loop, nothing, you know, extraordinary, yes. I've checked a bridge rectifier, fine. Not inline. Inline was showing, you know, but I desoldered it even, you know. And I've checked was fine, just to be on the safe side. I took one extra from the TV, yes. I've mounted. I've checked the same issue, so I was 100% sure that that's not a bridge rectifier, yes. And so yeah, I need to download 10.9 macOS because it turns out that the customer who gave me this fancy t-shirt the other day had 10.9 and I was asking which macOS you had and she couldn't reply. Then when I gave her 10.6 she said, oh, it was 10.9. Because she gave me such nice gift, I don't want to be rude and I don't want to make her extra, you know, hassle with extra money, so she'll just come drop off iMac and I'll just reinstall to 10.9. At least the updates hopefully will be fine because these updates don't do and it's just old-fashioned, you know. It's not the proper macOS for it. So okay, now what next? Okay, so about this one, yeah. So that was the beep for the macOS. My friend can help me download it. So anyways, what I want to say is I didn't know which cables what here because I knew that if it's not the electronics, yes, then it's off the mains. It's not in the mains, so I can touch, you know, like, you see. But because I didn't know which cables, I had to open this. And if you would ever open this model, it's Mighty Meg 100, this one from Sealy. Yeah, Sealy. So you've got this attachment here, like this, okay, and this goes off first, then this going off, and then I've used pry tool, regular phone and tablet and laptop pry tool, yes, and just moved this surface off this by using a leverage, so like this, yes, and I moved it and it went out, which I had a small problem with, but small, not a big one. So okay, then when you press this one, it's switching on. But these, now I know, now I'm smart ass, yes, so these are blue and red. So now I know that these blue and red will match these two green, yes, and then when I will press it, I should have a beep. If I don't have a beep, then this can't go on. And the issue with this welder is that the wire is not turning. Now it's a DC motor. When I've put on my best power supply, the lab power supply, when I've put 3 volts, 3.4 something was showing, max amps, max current. So it was taking 3.46 or something and 1.4 or 1.1 amp only. But it was turning, like it was proper turn, proper move. And I was trying, like push with something here, with this one, so the tension was like really hard, and it was still performing well. So I know that the motor is fine, the electronics is fine, the power is coming in, so only the connections somewhere are dodgy. So now the fun part, finding the connection issue, fixing the connection issue, and fingers crossed customers can take it, because that took me over 1 hour to do everything, to diagnose everything. One, I'm not experienced with welders, that's just general electronics, so you don't have to be. There's no even a microcontroller in it, nothing. It's just as simple as power comes in, there's one fuse, okay, just the regular glass fuse here. There is one small bridge rectifier, few filters, because you have to have filters, no wonder. Then you get a resistor, variable resistor here, yes, so that you get the control power of the wire speed. You've got a transformer, which gives you only one, why you're blinking, which gives you only one secondary coil output, so nothing too fancy, and it gives you 28 volts AC, I think. Then for that bridge rectifier, and it does give you 3 volts on output, yes, so I've seen about 278 or 3, something like that, so it was fine. Now the relay kicks in, so I've heard click click, few capacitors, few resistors, few diodes, so literally nothing too fancy, here. It's just, you can make this board yourself at home when you've got chemicals. I've got my somewhere. But anyways, so it's really nothing fancy. But can you imagine, like so much hassle over 1 hour? So I will have to probably charge customer for 2 hours of work. Why there is no recordings yet? Because you don't know there's no recordings, there's a recording per day. But I'm trying to do, as many recordings as I can, because then when I've got no time, I can do them. But I'm building 2 websites for 2 customers. One is for blinds, guy who mounting and producing blinds, and second is for the DJ. I'll brag about these websites later. And I'm making one website for myself as well. It's almost finished. That's my personal website, and that's something really exciting. I'm going on a holiday from 13th of July. So after the holiday, when I'll come back, and then we will start that project. It's awesome project. I'll tell you more about it in the next episodes, but it's thrilling project. So for now I'm doing only the market research. That's why I'm doing that website, to make a market research and then make a decision if I'll do it or not. If market research will show me that yes, go for it, full throttle in and we will do it. But what I want to say is, now this welding machine, we need to find the issue. So what we can do, these people have nothing better to do but just type, you know. Okay, so now when I'm pressing these two, when I'm connecting these two and pressing the button, I should have a beep, 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 beep. Be quiet. Now, when I'm checking these here, so that's second and fourth from the bottom. Second and fourth from the bottom. If I could only touch my props, you know, properly, yes. Second and fourth. Now if I will press it, it should be beep as well. And it's not. Where it's here, it is. Not anymore. Okay, so it is. It is. I was connecting it poorly only. So when I'm taking one to the red, one to the blue. Now, when I will want to check it, what I need to do is, I know that these ones are connected because these are blue and red, yes? So now I should be able to, I don't know if that's screwable or non-screwable. No, that's just one piece of plastic. And that just like squeezed in there or something. Anyways, that's okay. What I want to say is maybe I can make it. No, it's too short. But what we can do is we can get some extension tool. You see, like this. And now when I'll touch it, I should be able to get some beep. Okay. So we know that the red is connecting through this whole long wire to this place. Now that shouldn't connect with a blue, so I shouldn't get any beep on the blue side. No, nothing. And okay, so we know that it's proper circuit. Now we take the blue one, and because it's too far, we do the same method. So we inserted a rod, yes, which we know is conductive. Not on this side, so it's a break here. Yes, so here is, now it shouldn't connect through the red one, nothing. It should connect through the blue one. And it's not. So you see, now we know that the blue one is rubbish. Yes. Now we know that the blue wire is, it needs a replacement, needs a fix, or needs something to work back again. Oh! One time is working, second time is not working. Okay. That's weird. So now will be working. So it's an intermittent fault. No. No. And nothing. Again. So it's an intermittent fault. The question is only where this fault is. Because it has to be somewhere in the wire. Okay, so I can't believe they couldn't solder it even, guys. They just stick it inside. Just stick it to it. And they just wind it. Unbelievable. Like, really? You can't solder? You are so skinny on money? So sell it for £1 dearer, you know, and just solder it. No comment. No comment. It's just, I can't believe, you know, like, use a bit of flux, use a bit of solder, a bit of power, glop glop, done. Here's no. Okay, I'll pause it and I'll write to the customer that I found one issue, yes, and I'll be back. Okay, sorry guys, I'm back. I had to deal with some other customer stuff, but anyways, so now we know that the issue is with the blue wire, and before we will test even the green wire, which is going from the blue wire to the main board, we need to first make sure that this cable is working fine, because if it doesn't, then automatically, you know, you can't do anything else. So how we can check it? Well, the problem only is that we need to pull it, and I'm not joking. You need to try to make it worse before you can make it better. So you can disconnect this connector here, you can pull this through this hole. Okay, now what we can do is, because this is not working, this blue one is not working. I know you don't see it too vividly, but you can try to pull it, and in this case it's not helping. So the problem only is, if it's not helping, it can be anywhere. Usually when you pull in this, close to this connector, what's happening is you pull only the rubber, yeah, the condom. You just pull this one, and because there is no cable inside, because it's, you know, like connecting like this only, but it's broken here, that's why you've got this intermittent fault. Then what's happening, it's just loosen up, and you can see that it's expanding at one place, but I can't see it here, unfortunately. And because I can't see it here, it's a bit of a pickle. So probably I'll have to get some cable and just replace it. Ow! I'm making mess, guys. It's a weekend, so it will be tidying up, but nope, sorry. Who else is daring to reply to me? If I would have only you know, if I would have no time, I wouldn't be able to reply so often, believe me. But because it's a holiday, coming, so I don't live by calendar. So then, you know, if you build like 3 websites simultaneously, you manage 3 businesses simultaneously. Like I build 3 websites, and myself, I fix electronics, managing stock with them, with everything, sending some stuff to customers, getting stuff from customers, watching marketplace, getting stuff, you know, organized. Then you've got 2 other businesses apart from that to look after. You know, it's impossible. Literally, it's impossible to reply all the time as I do. Yes, you would not make money, literally. That's why with some of the jobs you need to charge, you know, like repair attempt fee. Yeah? You hear some noise. Okay, that's just dirty fans, but I won't be cleaning it now. The voice is raised slightly in my computer, I mean. Okay guys, so here I see that I can't pull it, so it's not looking like it's this side. Now again, here we can try to pull it as well. Okay, now here we could do some other trick, which is winding it, and then try to pull. You see, it's not going. Okay. So you pull from both sides and you see that there's literally no sign of, you know, releasing, yes? And if that's the case, it's quite challenging to, you know, to find the fault without opening this cable, and you don't want to open the cable, so guess what? You have to. You've got no other choice. And it's working, yeah? So it's an intermittent fault, it's not a proper fault. Now this one is a fourth one. 1, 2, 3, 4. So this one would be this. 1, 2, 5, 12, nothing. Oh. Okay. So okay. That's the fourth. Oh, Peter Pumpkin Eater. And no, guess what? It doesn't connect. So, this now. Okay, how many ohms? Let's check on ohms. 1.0 ohm. When I will 0 props, that's 0.8, so 0.7. So 0.2 or 0.3 ohm only we've got on the wires, yeah, on the wire. And here is similar because it's 0.9. So in that case, does that mean that only those white connectors don't want to connect, and that would be that's it? You know, if that's the fault because the manufacturer didn't care and didn't solder them, and that's only the fault in them, that will be ridiculous. You know, like ridiculous. I mean, because the rest is looking fine. You know, you can't see any other fault. Yeah, 0.9. Well, let's test this theory, okay? How we can test this theory is we can push these cables out. Okay, try to stick this back together. Okay, so let's do like, you know, I never open it, so yay, happy days. Let's put them together. It doesn't matter left or right, that just has to connect and connection has to go through. So, and there's no mark hot, cold or anything, so yeah, who cares? She walks like Rihanna, yeah? You don't make me trouble here, don't be naughty, don't be mean. Okay. So, do we have a deal? I've got no power, I will have to use a mallet. Who has a hammer here? I would have to go to other room probably for a hammer, because I don't have a hammer here, I think. Yeah, better. Is it? No, not better. I'm a liar. But okay, it's a button. That's definitely a button, and I see that I've done it the opposite way. I know because I was welding in the past, so I know that this button should be the other way around. But anyway, we get a meter. We can try to check it now. And press this button here. Oh, no. Oh yeah, good. Okay, either I'm connecting it, wrongly, or it's just fine and I'm exaggerating here. But anyways, let's take it apart. Okay, cool. Now we need to take it the other way around, because this won't simply work this way. Now it's right. Okay, cool. Now there is a small pin going out from this part, and this pin has a hole which need to match. Usually pins have to match the hole. Yeah? Oh, yeah, now it went in, so we can close it. Okay, now we can test the same thing with everything aligned, yes? So we can take these two, like this, and it is working fine. So, yes. Job done. I can't believe that's what I observed here, that the manufacturer fault is like that. Is like, really? Before me going and doing this soldering stuff on them here, I'll attach these two, I'll hide them. Okay, let's make some test, like literally, not because you can stand there under my umbrella. Come on, people, be serious here for a minute. Okay, so we've got insulation, we're safe and sound, and let's do some tests here. Take this power supply. Okay, take this power supply aside as well, and let's let's get the mains. Okay. And let's check this motor. Guess what? Nothing is happening. Okay, so we fixed the connection, but we didn't fix the issue yet. But at least we know that this gun is working fine. So that's a positive thing. Now, can we get a meter here and can we check the voltage? If any. How many times I have to wind it? So I know that there will be no voltage on the bridge rectifier, but it's like, am I 100% sure? Yes, nothing. So I'll put to AC and I'll put to the inner pins, because inner pins, if you would know, in bridge rectifier usually is a AC. Ooh, yeah, you have to be really careful when you work under the load. Yes, it's just, you have to do two things, like measure it and be careful so you don't short circuit something or kill yourself. So three things. Okay, so the AC is not coming. Now the question is, why the AC is not coming? Yes, because that's a good question. So we can switch it off and we can check these connections, which we are now are green through blue and red to green and back to the board. Okay, so that's second and fourth connector on this connection here. So we can get the beep sound. Yes, second. And beep. No beep. Literally no beep. Okay, let's get our magic connector. Into the one. Let's get something else into the second one. There is no power, no mains, so it's fine. Let's check on these two when we press. Okay, so we still don't have any fault on the way from and to the handle. Yes, so we know that 100% sure. So now is the problem in between only these two. So that's mean on the green connectors is a problem. 1, 2, 3, 4. So 1, 2, 3, 4. This. Okay, that's a problem. It's a drop of 1213 millivolts, so it is a problem. There is no connection to that. The same is to the other one. So now the second one, this one, to the second pin here. The same story. So it's looking like the fault is on the green cable, not on the long blue and red cable to the handle. So now what we can do is we can use my resistor just in case. I don't like to be, you know, I don't want to have fun with capacitors. Where are capacitors? Here. Where are other capacitors? Here, here. Okay. I don't want to be electrocuted. Where are the capacitors else? Okay, the rest is fine. So what we can do is take out these two, get this connector out of my way. Yes. Oh. Okay. And now check why and where this connector has issues. Nothing extraordinary in the socket. So let's get this pin. Let's use this pin to insert and test. But now to save ourselves a hassle, I'll take these two off. So it will be easier just to test it, you know. So now we grab this part and it's not. So now when I'll press that button, okay, this is fine. And this is permanent fine. So that's the second one. So it's looking like the connector only doesn't connect. It's looking like only the connector issue. So what we can do, we can open this connector like here, but I'll pause because my wife is shouting at the kids a bit. So guys, I'll be right back. Okay guys, so we're back. Now we've left on the connector, so we can disconnect these two culprits here, pull them out, power is off. Okay, good. You see, you've got those habits, you know, you have to double check the power because you don't want to make a joke here. Okay, so this type of pin is that you have to lift up the plastic thing here, and once you lift it up it will just pull outside. Oh, and it's going, it's pulling, it's coming out. It's no fun. Something is like blocking it or something. So let's, okay, so you got it. Okay, I don't see anything abnormal here to be true. I'll show you how it is. Okay. So it's nothing, no, nothing too special here, but it can't disconnect from here, you know, to here. But it does, you know, like really. So let's take a meter, and now it won't, because now the connection is robust, you see, and on the ohms it will show us 0.7, and when we will connect these two probes we've got 0.7, so we get 0 ohms. resistance. So that's mean only this here. And the problem is with this. So what we can do, before we will insert it, we can squeeze gently this part. I've got here some small pliers. I don't want to use the big ones, but get the small pliers. Oh, and maybe that can improve. Squash a bit as well this here. Okay, I don't want to exaggerate to be true, because you never know, it might not go smoothly after. Okay, and let's insert it. Okay, look robust. Okay, it's a bit tinier, so that's a good thing. Before doing anything else, I'll correct the second one as well, because we don't know which one was causing the problem, or both. So only makes sense to do two simultaneously. And the same story here, it's wide, really wide at the thinner part. I know you don't have the best vision, because we don't have the DSLR mounted here. Okay, I've exaggerated. I know I've exaggerated. Don't know if it will fit now, but anyways, let's give it a bash. Here has some issues to fit in. Need to give it a wee push. Okay, now we knew there will be an issue, but okay. Anyways, that's for sure more robust than it was. Let's connect this connector. Okay, let's scan now these two wires versus the board. So now the connection should be really robust. Okay, no beep. So that's the second one and fourth one. Nothing. So the cable is faulty? Unbelievable. Guys, I'm not joking, I'm holding this one here, and now it's a blue. Yeah, meter is working fine. Okay. Why the first one? The first one is brown one. Should be the second one. Okay, well that's weird, because I'm connecting to this one. So these two are connected? But that goes through there, through the wire, up to the red one, and that shouldn't be like that. I don't know why when I'm holding blue one, I've got nothing on the blue one, but I've got connection on the first one, and first one is a brown one. Oh guys, now I know. This went out. Well, that's a problem actually, because we don't want to deal with it more than we have to. And if we've got a problem with this, well, should be okay. Shouldn't be, you know, like, shouldn't cause any trouble. Don't know if you can see what I'm doing, to be true. I'm trying to fit this wire back where it belongs. And I had to change it a bit, which caused some issues. Okay, this has to be thinner. Okay, so 1, 2, 3, 4, so it should be here. Okay, now it went better. And the question is if it will fit or not. This will fit. No, that's the other way around. Sorry. Okay, let's make a test one more time. So the blue one. Okay, we've got the connection. And we've got the connection. Guys, so this is working fine. We can risk and put these white thingies. Okay, because we've got the connection. I need to move you now to the back. So see, there's no like huge issue with this welder, yes? It just that it has some problem. Okay, so now it's clicking. Now we've got a clicking noise. But the electricity doesn't go to the motor. When I was welding, I had a gas one, so when you press the button, gas was released, yes? But I don't know if you could hear the release, so I'll get you closer. That's the relay. Okay, so now it's a progress, because we had a problem with lack of relay. Now with the relay is kicking in, so one fault is solved. Now the last fault is to get the power to the motor, which motor works on its own, but doesn't work you know, through the button, and it should. That should trigger the motor. So then the coil, the reel, whatever, it passes the wire through. Okay? So now the question is, on the bridge rectifier, do we have an AC and DC? I don't like to touch it, believe me, it's never my favor. Especially that you know you're working with a high power, high current. I'm on the DC and I'm checking AC. Good. The jump is so small that we can't say, so let's switch to the DC and check the DC. So now it's showing 2.5 volt and 2 volts. Weird, so that's showing about 2 volts that it receives, but it shouldn't. It should receive at least 3 volts or something. That's first foremost. I don't know how much power this motor needs to start turning, because I would have to use my bench again to test it. But the question is, does this 2 volts goes to the motor? Because if it does, then that means another problem. I need to get the light. Yes, from what I see it's 0.00, so that means the power doesn't go to the motor. Now I can't touch it, you know, if you touch it you can blow. Okay, we get these 2 wires, which are the last ones, which are here. So these should be DC wires. Okay, so when I'm pressing probes and when I'm pressing the button, I've got only 0.1 or something, so the power is not going in. The question is where it's stopping, because if I see something on the bridge rectifier, that should go to the place where it should be sent. If it doesn't, that means something in between bridge rectifier and the motor wire, you know, it's faulty, yes? So now you need to diagnose which component is faulty on the way, replace the component or the connection, and make it working back, because now everything else is fixed, yes? Everything else is working fine. We need to turn it off. Okay, so let's use my resistor, yes. Okay, let's say I've done what I should do. If no, I'll be like, Okay. So now, on the way, I'll show you closer. On the way of these two, yes, these two are coming in, and these are 2 pins, these 2 pins. So from these 2 pins, you can see that it's blurry. That's what we can see. Okay. So these two pins, so this one goes to here, and there is a filter and some coil. Let's call it a coil. That's good enough. Now this coil goes through to the other coil, which is here. Yes. Now this coil again goes to this place and goes to here. What's here? That's a resistor, which I've tested and it was fine. Then that resistor goes here, goes to here. That's a capacitor which I've tested, which was fine. And it goes to the potentiometer. In potentiometer I've checked, so variable resistor, yes, I've checked and it was fine. So now we need to check the road. Now we need to check the road in between these and these two. So these two, which now are working fine, and in between these two, which are motor, because these are helping relay to kick in, switch on the power, excuse me, and pass on the power to the motor. But guys, I'm tired, to be true, and it's a 57 minutes recording. So yeah, let's call it a day. I don't want to do 2 hours recording because let's face it, let's do a part 1 for now. I'll try to diagnose it and then I'll record the outcome on it, or I will show it in the next day recording. If there will be no part 1 and part 2, then we'll be with another day recording with the newer date. But apart from that, you know how to diagnose it. Now it's simple, if you wouldn't fix it even, let's say there is a component which is impossible to get, yes? But you've got some other components which you can use, and you can pull the power from over there. You can attach this power, and then when you press the button, it will pass the current. If you can't, guess what? That's so low amp that you can use even external power supply to supply the power. And there is so much space inside it that you can even fit it permanently over there. So you can feed it from that power, excuse me, and then use that switch, that relay, so that you pass on the current onto that motor and it will work. So there are a few solutions which you can do. You can fix it originally, or you can find, other way to do it, yes? I prefer to, of course, use it the way it's supposed to be, so fix it the way it was, but not always is the case, believe it or not. Sometimes you've got a component which you don't know what the component is, and you need to observe by the design of the electronics to understand how it is working, and then just fit into that category and then test it and find. Like I desoldered from TV's power supply this, just to be on the safe side. I didn't have any spare one lying around, so I've used this bridge rectifier to make sure that that's fine, and it's fine, and now I know it. I don't have to second guess myself, yes? So that's the method of analysis, yes? So guys, thank you, and see you in the next episode. Bye bye.